Hello, calculus fans. I'm going to try to make a short video on partial fraction shortcuts. The other day when I mentioned this, a lot of people were excited about it. Again, the idea of partial fractions, very important general idea of taking a rational function and breaking up into its distinct parts. And I'm going to use a review sheet that I have from my last time I taught differential equations. But let's just start with an example to sort of get us going. So if somebody gives me x squared plus 2 over x cubed, it's already reduced because the power on top is smaller than the power on bottom. So the next step is to factor the denominator. In this case, an x factors out. It's x squared plus 3x plus 2. And then the next step is to keep factoring. So you've completely factored it. And you might have to think about, is that irreducible? But before, the next step is to try to think up factors. And I think this does factor nicely. X plus 1, x plus 2. Okay, so in class we talked about what the decomposition is. That you write a over x plus b over x plus 1 plus c over x plus 2. So this video is not about these pieces. This video is about finding a, b, and c and more. Okay, so there are many ways. And in my sheet here, I talk about how you write this out. I talk about how you can solve for the constants by comparing coefficients. And then I talk about how you can plug in special numbers. And for Math 125, that's all you need. And you can always check at the end if both sides are equal. There's many things you can do. And it turns out if you do the shortcut method, you clear both sides, x squared plus 2. And it really does not take very long to do this. Again, this video is for people that have already thought about this a little bit. So if you're still stuck here, please go through and stop and see if you can get the answer. But we do these special methods techniques. So this is pretty darn fast. You plug in a 0, that makes this 0 and this 0, so you'll get that 2 equals a times 2. Because put in a 0, this will be a 2, so a has to be 1. Then you can do a similar thing for b. Plug in negative 1. That's 0, and you can find b, and you can find c. When you do that, and you might even notice this for a, when you plug in 2, when we plugged in 0, somebody long ago noticed, but those just go away when you plug in 0. So it's like you're getting rid of this term right here. And the other numbers are just going to be whatever happens when you plug in 0 here and divide. So if you look at that, a is going to be whatever this is when you plug in 0. And that's how someone came up with the so-called cover-up method. And the cover-up method says this: if this is x squared plus 2, and this is x, and this is x plus 1, you do have to be careful using this, but it actually makes it so you could do these problems really fast. Now, in Math 125, I don't advertise this because there's not an easy way to check your work. You have to make sure to do it right. But in future courses, when you're trying to be quick and you're doing long problems, this might be helpful. So anyways, the cover-up method is to cover these two things up. So cover up this and this. And whatever makes that 0, which is 0, plug in for the rest of them. So plug in a 0 here, plug in a 0 here, plug in a 0 here. And that's going to give you 2 over 1 times 2, which is 1. That's a. It's super fast when you see it. And then this, now we're going to take a negative 1. And we're going to plug in you can't plug in a negative 1 here. So we're just going to cover that up. But we're going to plug in a negative 1 here, negative 1 here, and a negative 1 here. It's going to give me a 3 on top because it's 1 plus 2. And the bottom, it's going to give me a negative 1 times a 1. So this is negative 3. But it's really just thinking through what would happen if you plugged in a -1 over here. So it's just a slightly shorter way to do the shortcut we're already doing. But you can see how if this is something you were going to do a lot of, then that could be really fast because you can see without any of this, even without this, you can see the answer. So pretty fast. Now the problem is it's only for distinct linear terms, and so you still would need to know the technique. So it's not that we're trying to be mean to you teaching the technique, but the last one you can try this out. Put a -2 in there. Well, you can't put it in that one, so you put it in the other ones. This is the so-called cover-up method. Oh, sorry, I lost the square, didn't I? I was like, well, that's giving me 0. Something's wrong. So this is going to be, when I square, it's going to be 4 plus 2, so it's going to be 6 over -2 times -1. +3. Done. So you can see if you practice that, you can get really fast. It matches up. Now the problem is what happens when there's a repeated term or an irreducible quadratic. So I go through and then do several more examples in this review sheet. I talk about here's an irreducible quadratic. I talk about, and I find the numbers by the standard techniques. This is a good practice sheet if you just want to practice that step. Here's one with a repeated linear term. And so the repeated linear term, I have to be honest, is I don't even remember it myself. So we're gonna pull up, I'm gonna use my own review sheet, which I made, to remind me how I did this. So again, I would disregard these shortcuts, but I hope this gives you a deeper understanding. So we're gonna write the composition. And we're going to try to find A, B, and C. Cover-up method doesn't work here because you only have 2 things to plug in, but 3 things to find. Okay? So I like comparing coefficients. To me, that's the best way to go. But I did, when I was teaching this class last time, I tried to come up with a way. So we already talked about that. The cover-up method, for this example, says cover up the x plus 1. And when you do, it's kind of like we're thinking of multiplying by the x minus 2 squared. So this, I had to remind myself how this goes. The numbers in our third example. So you can see this is why I don't teach this, because it doesn't always work. So that 5/9, let's see if we can get that 5/9 out. Sorry. I should have thought about this more carefully. But if you put a -1 in here, then you do get 5/9. So it still works for this term. For the distinct linear term, the cover-up method still works. So it can be kind of short for that piece. I think the same method works for the C, meaning if you put in a -2 here, we'll check with my answer in just a second. You're going to get -1 because I'm putting a -2 in there. I think C is indeed -5. Is it? No, it's not. Wait, was the original number 5? Did I copy down right? See? I don't know the method. Don't trust me. Ask someone who knows more. The cover up this in the denominator on the left-hand side, and then plug in. Oh, it's because I plugged in a -2. I should be plugging in a +2. 2. All right, I was thinking right. It's 5/3. The problem with that is you still have this term, which you would need to solve by some other means. In which case, has the cover-up method worked? Sort of. It found a couple answers, but I still am going to have to think through how to get the other answer. I don't think complex numbers really make things shorter. So that's it. For those of you that are interested, there's the cover-up method. But I will put a link to this sheet in case you just want to practice. Now, this sheet does have, this particular example is really more specific to Math 207. I don't think we'll have something like that on ours. This we do have. So examples 1, example 3. example 4, and a little bit of commentary. So you can see none of that is really that much faster. But since there was a request to discuss the cover-up method, I thought I'd make this short video. All right, hope that's interesting.